All right, geometry. We have conditional statements today. These are basically if-then statements. If this, then this other thing. Okay? So a conditional is that statement. A conditional is a statement with a hypothesis. So basically your if part. So when you're thinking of the hypothesis, it's if this. So let me write that a little different here. Hold on. There we go. So the hypothesis is your if part, and then the end of it is the conclusion. Okay, which is the then part. If the hypothesis, then the conclusion. Okay, that's an if-then statement or a conditional. All right. So if-then form, we usually use these two letters, P and Q. So if P, then Q. Okay. That can also be written as P to Q, an arrow kind of going from if then to then. All right. So this will make more sense with some examples. So write the statement in if-then form. So it says x is odd and 2x is even. So the first part says x is odd. So if x is odd, then 2x is even. Okay? And then from there we can kind of decide if that's true or not. Okay? So that's kind of how we write if-then statements. If one thing, then the other thing. Okay? And then this symbol here, okay, kind of what we put on top of a congruent sign. It's called a tilde. This is writing the negation of a statement. Negation means this is not. Like if x is not odd, then 2x is not even. Okay? So let's look at a couple examples here. Oh, and right here, the negation of the hypothesis in example 1 would be if x is not odd. Okay, so you just make it a not instead of is not odd. Okay, so for this table here, we have 3 other forms. So this first one is just the conditional. Okay, if then, if P, then Q. Okay, so if P, then Q. This is P, this is Q. If x is odd, then 2x is even. Well, 2 times anything is going to be even. Okay, now the converse, we switch the P and the Q. All right, so in this case, it's going to be the top one's P implies Q. Now we're going to switch the order, say Q to P. So if 2x is even, then x is odd. So I just switched P and Q, or this phrase and this phrase. Okay? Now, if 2x is even, couldn't I say 2 times 4 is also even? So that is not necessarily true. So we'd say false. Okay? Now, we don't need to find a counterexample, but if we did, we could say 2 times 6 is 12. Okay? X is 6. All right? So if tilde P, then tilde Q. So this, remember, is not. So if not P, then not Q. So I'm just going to go P and Q, but not. So if I'm going to go say, if x is not odd, then 2x is not even. If x is not odd, that means it's even. And if 2x is not even, that's not going to be true either for the same reason. Okay? And so the last one is not q implies not p. Not q implies not p. So I'm switching it. If 2x is not even, then x is not odd. If 2x is not even, then x is not odd. Well, that's got to be true, because if 2x is not even, that means x has to be some kind of decimal or fraction. So it's not going to be an odd number. Okay? 2 times anything should be even if it's a whole number. All right? So let's go to the back side here and continue looking at our conditional and such statements. So in this case, it says, write the statement as a conditional, then write the converse, inverse, contrapositive. Okay, these are terms we're going to have to really get used to. So you'll want to say those: conditional, converse, inverse, and contrapositive. Okay, so again, this first one is P implies Q. So if the first part, then the second part. So if, in this case, it's talking about linear pairs are supplementary. Okay, so I could say if 2 angles are a linear pair, then they are supplementary. Well, we know a linear pair tells us that 2 things are supplementary and adjacent. So if the first part is true, then the second part has to be true. Okay? So in the second one, this is Q implies P. Converse, you switch it. So if 2 angles are supplementary this time, then they are a linear pair. Now, we've talked about this before. When it says 2 things are supplementary, that doesn't mean they automatically have to be next to each other, right? So a linear pair has to be next to each other. Supplementary doesn't. So this would be false, because what if I had like these 2 angles? Okay, those might be supplementary, but they're not next to each other. So that would not be a linear pair. Okay? So the next one, we have not P implies not Q. If not P, then not Q. So if not P would be 2 angles are not a linear pair, then they are not supplementary. Well, that's the same reason. Okay, if 2 angles are not a linear pair, it doesn't mean they're not supplementary, it just means they're not next to each other. Okay, so that'd be false. And then lastly, we've got contrapositive, which is not Q, then not P. So if not Q would be not supplementary. So 2 angles are not supplementary, then they are not a linear pair. Okay, so if you think about that, if they're not supplementary, a linear pair, to be a linear pair, you have to be supplementary. So if it's not supplementary, it automatically cannot be a linear pair, so that would be true. Okay, so our last one here, let's look at integer is divisible by 10. So if you think of things divisible by 10, that means you can divide it by 10 evenly. Okay? So if an integer divides by 10, by 10, then it ends in 0. That is true. Okay? So that is P to Q. Integer divisible by 10, ends in 0, Q. Okay? So this is switching them. Q implies P. So for the converse, if an integer if an integer ends in 0, then it divides by 10. Is that true? Well, 0 ends in 0. Okay. Since 0 ends in 0, that would not be the case. If an integer ends in 0, and 0 is an integer, that would be false. So not Q, that would be, so not P implies not Q. So if not P would be an integer is not, or does not, let's say. If an integer does not divide 10, or by 10, then it does not end in 0. That would also be false. If an integer does not end in 10, then it does not end, or divide by 10, then it does not end in 0. And that's true, because if it doesn't end in 10, there's no way it's going to end in 0. Okay? Or, sorry, if it ends in 10, it does not. So 0 would be another example of that. Okay? And finally, we have not Q implies not P. So if an integer does not end in 0, then it does not divide by 10. And that would be true, because to divide by 10, it's got to end in 0. Okay? Now, the reason these two are false is because of 0. That is an integer. Okay? So you got to kind of figure out which ones go with what. But something to keep in mind here is when you're looking at these, see how these two go together? These two go together. Okay? So something to keep in mind is when you're going through these different things is if you have a conditional statement, so I'm going to highlight this one. If you have a conditional statement that's true, then your contrapositive is also automatically going to be true. Okay? They go hand in hand. If it's false, then the contrapositive is going to be false. Same thing for this. Okay? If you have a converse that's false, then the inverse is also going to be false. Okay? So keep that in mind. Those two, the two first and the last go together, and the middle two go together. Okay? So we'll have to get more practice with this, but for now, go ahead and practice that, and this one's done. Peace.